In this SwiftUI tutorial, I'm going to answer one of the most common questions people have when using SwiftUI. What the heck is state and why should they care? When you use SwiftUI, you'll see things like this: @state, @object binding, and @environmentObject. And if that wasn't confusing enough, you'd also see things like this: $show advanced options. What do those @ and $signs mean, and when are they needed? In this video, I'll be explaining exactly how state works in SwiftUI, and more importantly, how state, object bindings, and environment objects are different things. By the end of this tutorial, you'll know exactly how SwiftUI manages state, how each of its options work, and which to use in every situation. We've got so much to do, let's get started. In Swift, structs are immutable, which means they have a fixed value and we can't change that. Swift relies heavily on structs. We use them for almost everything. Integers, strings, booleans, arrays, dictionaries, sets, tuples, and more are all structs, which means all have fixed values. Being fixed in value means we can't just change them when we please. Think about it. It doesn't make any sense for me to say that I've changed the meaning of 5 to equal 6. It's nonsense. SwiftUI follows the rest of Swift in using structs for its views. That means when you design your layouts, most of the things you're working with are structs. So structs are simple things that are fixed in value, like strings and integers. And SwiftUI uses structs for its views. But what does all this have to do with state? To find out, let's look at some code. First, I'll make a property called isAuthenticated equal to false. Then, inside the body, I'll make a button that toggles that boolean with the text toggle authentication. This boolean here is state. It's something that tracks the way our program's configured and changes over time based on user interactions. When we build this code, Swift complains. We're trying to change a property of our struct, and like I said, structs are fixed in value, so that isn't possible. Obviously, this causes a problem, because we need to make changes to our program state all the time. So how can we fix this? Swift 5.1 introduced a new feature called property wrappers, which allows us to write custom code to handle the way properties are created and stored. For example, if we want a lazy property in Swift, we change this, var reverse name is a string, and return string name reversed, to this, lazy var reverse name is a string, equals, and then put parens after the closing brace. If you think about it, that lazy keyword is doing a lot of work for us. Swift won't do any of the work to calculate the reverse name until it needs to. And when we do run it, the value will get stored away so the work isn't repeated. The lazy keyword is actually baked right into the Swift compiler. It's designed as a hard-coded language feature, which means we can't make something like it ourselves. Or at least, we couldn't. This is exactly what property wrappers are designed to let us do. With property wrappers, we could design our own version of the lazy keyword entirely in Swift. So, on one side we have SwiftUI using structs for views, which means we can't modify properties in our views. And on the other side, Swift gives us property wrappers to control the way we create and store properties. In SwiftUI, these two features come together to do the impossible. It gives us multiple property wrappers that allow us to modify state in structs. Yes, you heard that correctly. SwiftUI lets us modify state inside structs. To demonstrate this, we can go back to our earlier code and use a property wrapper, just by adding @state here. The @state part is a property wrapper that tells Swift that this property will change over time. It's part of our program state. If you imagine our struct as a chunk of data that sits in memory, any properties we store are in there too, which means we can't change them. But when we use the @state property wrapper for a property, it comes out of the struct and is stored somewhere else, somewhere that's managed by SwiftUI and can change. So when you see @state before a property, it means this is data that's going to change as my program runs. So let SwiftUI take care of its memory for us. But there's something even cleverer here. You see, one of the other things @state does is let SwiftUI monitor for changes. So when a state property changes, SwiftUI knows to automatically reload its views so they reflect the new state. So if we had a username property, we could use it in a view like this: text, welcome, string interpolation, username. But if we use the @state property wrapper, anytime the property changed, SwiftUI knows to automatically reload the body of the view, so the welcome message showed the new name. We can actually see this in action if we use a little bit of GCD code. @state var reload count equals 0, dispatch queue.main.async after deadline now plus 1, self.reload count plus equals 1, and then return text reloads string interpolation reload count. That code increments reload count by 1 after a second has passed. But when we change reload count, SwiftUI will also reload the body of our view, which will in turn run the GCD code again, and the counter will keep going up. So the @state property wrapper lets us modify values in our views over time to reflect the changes happening in our program. Even better, when we change one of these state properties, SwiftUI knows to automatically reload our views. Anyway, before I move on, there's one more thing I want to talk about. This code creates a username property and uses it inside a text view. As it's marked @state, the text view will be reloaded when the property changes. We can say that the value of the text is bound to the value of username. When username changes, the text view must update. But what happens if the property is being used in something that's editable by users? For example, if this text were a text field instead. When the username property updates, we want that text field to update too. But when the text field changes, we also want the username property to change. The two need to stay in sync. To solve this, we need to bind the property to the text field, so when the property changes, the text field updates. And we also need to bind the text field back to the property, so any changes to the text field are saved in the property too. This is what's called a two-way binding, a binding where data flows in both directions so everything stays in sync. Now, of course, we don't want to have to write code to handle all that synchronization of data. But fortunately, we get that functionality for free, thanks to those property wrappers I mentioned earlier. When you see a property being used just by itself, like username, it means you want its value to be used there. Swift will replace that property name with its value when the code runs. But when you see a $sign before it, you're actually accessing the value through its property wrapper, and that allows SwiftUI to take care of the two-way binding for us. So text SumVar reads a value. Text field $SumVar reads and writes a value. So that's how @state works. It asks SwiftUI to take control over a property so its value can change over time. And that's also how $SumProperty works. It's a two-way binding between a view and a property. So when one changes, the other is also updated. But what if you have more complex data? Let's take a look at another example. Here we have a view that has several state properties: a username, a password, and an email address. Together, those represent a user in our program, and we might write some code that lets them edit those properties. Text field $username, text field $password, text field $email address. But what happens if we want to send that user data to other views in our app? Or save it for later? Or transmit it over the network? We could just send each of the values individually in all those cases, but that isn't convenient. What we really want to do is wrap them all up in a single user type that can be passed around as one object. For very simple situations, we could move those properties out into a struct, then use an @state property so when any part of the struct changes, it will reload our view. We could say struct user, and then paste those properties in. I then create an @state property for that back in my content view, and update my three text fields to be bound to user.username, user.password, and user.email address. That works fine when the user is only available in a single view. But what happens when multiple views need access to that same user? Then we have a problem. You see, as well as being immutable, structs also only ever have one owner. This means if you create an instance of a struct and use it inside several views, they all have their own unique copy of that struct. So if one view changes the username to be 3 straws rather than 2 straws, all the other views won't be updated. This means different parts of your app will have different ideas of what the same data should be, which is a recipe for disaster. Having to share state across multiple views is such a common problem that SwiftUI comes with a great solution for it, built right in, called object binding. The best way to understand how it works is to take our current code and upgrade it. So here's our current code. I'm going to change user to be a class. Classes are reference types in Swift, which means they create an instance of our user class we can pass it into many places, and they'll all share the same value. When a property changes in one, they all change. Remember, we used @state before making a struct, which means that we were giving SwiftUI control over how that struct was created and stored. Every time the struct changed, SwiftUI could detect that because it was being recreated, and it would automatically update our UI. But classes don't get recreated when their values change. We can change them in place. This means SwiftUI can't automatically detect changes, so it can't automatically update our UI. To fix this, we're going to bring in the combine framework. Combine is Apple's way of letting us process values over time, which is a fancy way of saying we can make things that watch for changes, and make other things that announce changes. In this case, it allows us to make a class that can announce when it's changed so anyone watching the class can respond to those changes. First, we import the combine framework. Next, we create an instance of pass-through subject, which is Combine's way of sending notifications when changes happen. We get to specify whether we want to send anything specific to whoever's watching us. And we also need to say whether those updates might throw errors. In our case, we don't want to send anything other than saying a change has happened. And we'll never throw errors, so we'll say void and never. var did change equals pass-through subject, angle brackets, void, never, parens. So now we have a way we can tell the world when values in our class change. We can ask that pass-through subject to send an announcement to whatever's watching. So, if we want to send that announcement whenever our username changes, we'd add a property observer like this. didSet, didChange.send. In this case, we wanted to send notifications when any of our three properties change. So we'll add didSet to the other two as well. So, now anything watching our class will automatically be notified when it changes. But that's only half the problem. How can we tell SwiftUI to watch for those announcements so it knows to update its UI? Obviously, we don't want to write all that code ourselves. We want something like @state that'll do all the monitoring for us. Of course, SwiftUI comes with a great solution baked right in called @object binding. This is another property wrapper, and it'll cause your view to watch any object for changes that get announced. And when it happens, it'll reload its UI. So I'll replace @state with @object binding. The only change we need to make that work is to make our user class conform to a protocol called bindable object. This protocol has a single requirement, which is that we must add a didChange property that announces when changes happen. But we already added that, so SwiftUI can now watch the changes. To try it out, let's make two of our text fields point to the same property on the user class. Now, when we run the program, typing in one text field will automatically update the other. This happens because our didChange property is announcing those changes to whatever is listening. And now that our Swift view is watching, it'll detect those changes and reload the view. Even better, because we're using a class, we can now share that single user instance in many parts of our app. And SwiftUI will automatically keep them all up to date. So if one view changes the username, all the other views will automatically update. Please just stop and think for one moment about how amazing that is. Before, we had the problem that different parts of our app could get out of sync with each other because they had their own copies of data. Now though, SwiftUI does away with those problems entirely. All parts of the app automatically stay in sync. So now we've seen @state for simple properties like strings, integers and booleans. And we've also seen @object binding, which is great for complex properties like custom types, and for when you want to share one piece of data in many views. Before I move on, I want to add 3 more things that come about as a result of the things we've learned so far. First, when you use @state, you're defining something that belongs only to the current view. It's not designed to be passed around. As a result, Apple recommends you mark all your @state properties as private. Second, whenever you want to use a reference type for some state, i.e. an instance of a class, you always need to use @object binding so SwiftUI knows when their values change. Third, whenever you're announcing changes in your bindable object classes, you must always do so on the main thread. SwiftUI, like most user interfaces, only works on the main thread. And because your update announcement will cause a UI refresh, it must happen on the main thread. So that's @state and @object binding. But there's a third option here, @environmentObject. This is another way of working with state in your app, and it's just as important as the other two. Now, I know what you're thinking. Why do we need another way of handling state? Surely between @state and @object binding, we have every base covered. Well, not quite. Let's say a user logs into your product and starts browsing your storefront. They select a product to buy in your app. Then you ask them where it should be delivered. Then you ask them what speed of shipping they want. Then you ask them whether they want gift wrapping. Then you ask them to enter the payment details. And finally, boom, you save the order to your server. User 24601 ordered a loaf of artisanal bread to be delivered tonight, with no gift wrapping because, well, it's a loaf of bread. In order for the last part of our app to know what user placed the order, we need to pass it to screen B, C, D, and E, even though none of those screens actually want or use the information other than just passing it along. Now, wouldn't it be great if we could automatically share that user in any view that needed it? Well, that's exactly what @environmentObject is. Shared data available anywhere. So, rather than passing objects down a long chain of views, we can instead put them into the environment, so any view we embed or present automatically gets access to that data. And before you ask, yes, environment objects automatically stay in sync just like object bindings. Which means if two views share the same environment object and one changes it, the other one updates as well. In fact, it even uses the same bindable object protocol, so you already know how to use it. The only difference between an environment object and a bindable object is how we reference them. Because environment objects aren't passed to views, we don't have to give them default values or pass them inside initializers. So we could just take our existing user and say we'll get it from the environment rather than being passed in explicitly or creating our own. An environment object, var user, is a user. That means user no longer has an initial value, and there's no custom initializer for it, which means it's possible for it not to exist. It's possible for this view to be created and shown without us ever actually providing that value. And Swift doesn't even complain like it normally would. That doesn't mean it works though. In fact, if we try resuming the preview, you'll find that it crashes immediately. We've told SwiftUI that the user property will come from the environment, but it isn't there. It's a bit like implicitly unwrapped optionals. We're making a promise that it'll have a value, so Swift won't try to check that's definitely true before using it. But if we're wrong, if the data we said would be there isn't actually there, then our app will crash. The fix is pretty easy. We need to create an instance of our user and place it into the environment so SwiftUI can read it. So, in our scene delegate, we might make an instance of our user data as a property. We create it once and keep it alive. var user data equals user. We can then pass that into our content view like this. .environmentObject, user data. Those changes are enough to make our program work great when it's run. But it'd be nice to have the Xcode previews working well too. Those don't come from the scene delegate though. They come from a special part of our content view code, down in that #if_debug section. That code's only run when we're in debug mode, when we've pushed the app directly from Xcode, so it's safe to make test data right in there. So I'll head back to contentview.swift, and down here I'll make some space and say let user data equals a user, content view dot environment object user data. And now we can resume the preview and it'll work great because it has some example environments to work with. Now, if there's one thing that confuses folks when they first start using the environment, it's this. How does Swift know that the environment object we passed in belongs to the property inside our struct? After all, we wrote no code that puts them together. Well, behind the scenes, the environment is effectively a key value store, like a dictionary, where the types of an object are the keys for the dictionary. So, when we place an instance of our user class into the environment, SwiftUI will automatically use that for any environment objects that are of type user. The great thing about environment objects is that they break our long chain of data being passed around. If view A creates a user, they can stash that away in the environment, then present view B, which presents view C, which presents view D. And then view D can read the user from the environment, rather than having it passed along the chain. And again, don't forget that when one view changes an environment object, all other views using that object get notified and update their UI. We get all the benefits of sharing objects without the hassle of having to watch for changes ourselves. The important thing to remember is that the environment flows downwards. If view A puts something into the environment, then any views it shows can read that value if it wants to. Or any view shown by those views, and so on. But that does not mean some other unrelated view will get it. Only views that have view A as an ancestor will. SwiftUI makes extensive use of the environment. Things like dark mode and dynamic type and size classes all come from the environment, so any view can use them whenever it needs to. Anyway, we've now covered @state, @object binding, and @environmentObject, while also looking at the $sign for two-way data bindings. So let's summarize. Use @state for simple properties that belong to a single view. @state properties should usually be marked private. Use @object binding for complex properties that might belong to several views. Anytime you're using a reference type, you should be using object binding for it. Use @environmentObject for properties that were created somewhere else in the app, like shared data. Make sure you set them in the environment before use, otherwise your app will crash. And those $signs just mean you have a two-way binding. SwiftUI will read and write the property as its value changes, to make sure your properties and their UI stay in sync. So that's the end of this tutorial video. I hope it's given you a deeper understanding of how SwiftUI works with state and how to effectively use all the various options available to us. Anyway, if you enjoyed the video, please hit the like button and don't forget to subscribe to my channel. I make lots more videos like this one to help you improve your skills as a Swift developer.